Yes.
Nowadays.
Yes, dear.
I just like to have a negative because the first one is negative.
Okay, that's what I did as well. Thank you, Caitlin. So everybody doesn't have an X. Not everybody has a Y. There's a couple people with a 9, but not everyone has a 9. The only thing I could factor out was a -1, and I love the fact that she doesn't even write the 1. She just put negative x cubed y to the 6th plus 10x to the 4th y plus 9y squared minus 9. Everyone's sign changed. That's all she did for the bell ringer question. Okay, and then for some reason that reminds me, we had a meeting during our 5th period to look at our Aspire results for the 9th and 10th graders in here. And 8th period is my only class that went down. But I think the reason we went down is we had a lot of people absent that day. Like I noticed, I know Juliana was absent and there were a couple others absent. So our scores went down. Anyway, my whole point is eventually I'm going to make a data board. And when you see that your data went down, don't let it bum you out. There's a reason our data went down. We didn't have everyone here the time we did the Aspire interim. That's why it went down, because we didn't have enough people. That's part of it. Okay, now back on track. Tell me how to do number 2. Yeah, like we needed you. Okay, yes, dear. I would love to know how someone did number 2. Yes, dear. Tell her ahead and tell me again.
So that's the proportion.
Yes, that's what I want to hear. Tell me.
295 on top, and then 10,000 on bottom,
Okay. Now what?
and then x on top, and then
Million.
and then you would cross multiply,
Yes, and what did you get as your final answer?
and you would get 6 as your final.
Perfect. Okay. Someone in 1st period did it a completely different way than this. I'm most happy with Kaylee's answer because it shows me she understands what we've been doing lately. She put the data from North Carolina, the 295 and the X, in the numerator. For the whole USA, the 10,000 and the 300,000 she put in the denominator. She cross-multiplied, she solved. I'm pretty sure either she did well on her last test, and if she didn't, Lord knows she's going to do well in this next test. Setting a proportion, cross-multiplying, that's what I wanted to see. Perfect. Okay, forgot to grab mine. So you got out the 7 and 5 notes. So I say they're really easy, and there's good news and bad news. The good news is they are easy. The bad news is that there are some terms that we've not been over in a while. Now, we were in a hurry back in Chapter 5 because we wanted to make sure we finished through the whole chapter before the end of the semester. So we only talked about vocab when it came to altitudes and when it came to medians. So we've not actually done math problems with altitudes or medians. We've done plenty of math problems with angle bisectors, though. So that's not the case. You know what an angle bisector does. What does an angle bisector do? It cuts the angle in half. So if you need a little note, angle in half. It cuts the angle in half. Not Juliana. Not Caitlin Smith. Do not answer this question. Looking at the examples 1, 2, and 3, which one involves an angle bisector? Number 1, number 2, or number 3? Look at 1, 2, and 3. Which one's cutting an angle in half?
2.
I hear 2 and 1. Which one is it?
1.
Why is it 1?
Because it's got the rainbow.
It's cutting the angles in half. Yes, exactly. So it is 1. They're cutting the angles in half. So let's talk about median. It sounds like we talked about medians happen in the center of the highway. So median, I hear the word middle when I think of it. And it's cutting a side in half. Look at the side length. It's cutting it directly in half. That's why we have the congruent symbols. So an angle bisector cuts an angle in half. A median cuts a side in half. Okay, well, we already said it's not 1. It's 2 or 3 involving medians. 3. You can tell from the markings that it's going to be 3. 3 involves medians. And last but not least, we have altitudes. An altitude goes from a vertex to the opposite side. And, of course, the important thing is there's always a right angle. So notice with an altitude, you have a right angle. So clearly, 2 has to be the altitude example because I see right angles. Now, do I actually expect on every example for Savannah to say, oh, this is an altitude, oh, this is a median, oh, this is an angle bisector? No, but potentially she might need to know that.
So if it was altitude, did they have right angles?
Yes, like number 2 has right angles.
Oh, okay.
Okay. That's useful to know, yes. Does the geometry teacher want her to know that? Of course. Would that slow her down from working these problems? No. Okay, so remind me, before we go too crazy, all these definitions say if 2 triangles are similar, if 2 triangles are similar, if 2 triangles are similar. What makes shapes similar? There's 2 things that make shapes similar. You can find the scale factor, which means the sides are proportional, but then the first thing you should check is what? Do all their angles match? Are all the angles congruent? Because if not, then you can't do anything. They're not similar. There was one on the test that was not possible. They were not similar because their angles did not match. Okay, so now we got all that. We're told in all of these problems, notice the symbol, we're told everybody is similar. Similar, similar, similar. I see that symbol over and over. So this only works if we're told from the beginning people are similar. But if they are similar, then we get to do what we would like to do and set up a proportion. I'm going to use colors to try to help me out. But if I do x over 15, what would I put in my other fraction?
15 over x.
I did x over 15. I would do 8 over 12. So I did x and 8 went together, they're both in the numerator. 15 and 12 went together, they're both in the denominator. I like to set it up where each triangle is a fraction. So x over 15, 8 over 12. Okay, we cross multiply, we get 12x equals 120, so x equals 10. Perfect. Are there any questions about that one? I set up my proportion, I cross multiplied, I solved. Now, could your proportion look differently than mine? Yes, you could have both of those in the numerator and both of those in the denominator. Yours could look different than mine. You do not have to be my equal twin. But if Savannah puts this in the numerator, she better put this in the numerator too. She can't do x over 15 and 12 over 8. She's going to get the wrong answer. She's got to make sure x and 8 go together, 15 and 12 go together. Okay, so saying all that, what should Savannah do theoretically on the next problem? Why? Of course, she and I both like to color things. What will her fractions say? 20 over x?
15.
Are you sure?
20 over 15.
I could do 20 over 15, but I like to do one triangle is one fraction, the other triangle is the other fraction. It's just my personal preference. So go with me.
So 20 over 16
Okay.
equals 15 over x.
Okay, perfect. Now what Savannah was saying before then will work, but I try to be consistent since everyone sees what I do. I try to always put one fraction with one, the other fraction with the other triangle, 15 over x. It just, that way I'm being consistent when I explain it to others. The way she said it would have still all worked out. Okay, so I cross multiply, I get 20x equals, I don't know, 240, so x equals 12. Yay. Okay, and then we get to our last example, and again, Cassie's understanding how I'm setting all this up. She really didn't have to know anything about an altitude or a median. She just has to know how to set up a proportion. What would I do on the last one?
X over 13.5
Okay, x over 13.5.
equals 3 over 9.
13.5 equals 3 over 9. Perfect. Okay, you cross multiply, you get 9x equals, I don't know,
40.5.
40.5, so x equals 4.5. Perfect. Because these are such, I'm sorry, they're kind of nice, easy problems. So anticipate a lot of decimals. I know 40.5 divided by 9 is 4.5. It doesn't look right, I know, but it is. I saw the look, Juliana, but it is. Okay, so far, you can do all of this. None of this is a problem. There's only one more thing for me to say, and then you can handle the whole worksheet. The last thing I need to say is you probably want to put a star by. It's called the triangle angle bisector theorem. It says, if we have an angle bisector, so step 1, is the angle being cut in half? It is. You need to check that first, or else there is no angle bisector theorem. Okay, if the angle is being cut in half, then the opposite side is still proportional to the whole triangle. It says the two segments that are proportional to the lengths of the other sides, which makes no sense until Miss Compton actually does some math, because that's where me just coloring stuff does nothing. So for instance, I'm going to do number 5. Yeah, I did blue and then I did gray. It's hard to tell. Let's just look at number 5. So on number 5, angles cut in half. If I do 4 over x, I'm doing that piece. Then what would I put in my other fraction?
6 over 13.
6 over 13. I did the 4 and the x, and it goes with the 13, and that goes with the... Exactly. So 4 and 6 are both on the sides. They're down here across from the angle that was bisected. X and 13, you got it. So I cross multiply, I get
6x
equals 52. So x equals
8.67.
okay, 8.67 sounds great. I know it was 8.66666. 8.67 is going to be great. Okay, why? Why, oh why? Did I do number 5 before doing number 4 or number 6? They are easier. What makes number 4 and 6 harder?
Because it's long.
Oh my goodness. So we're needing to put some number here. I need a number to go there. I need to do 11 over whatever that number is equals 14 over x so I can cross multiply. They didn't give me a number. Oh no, what am I going to do? Any guesses?
You divide it.
Every class has guessed that, and it's not a bad guess. It's not a bad guess, but if that were true, then how come those numbers don't match? That wasn't divided by 2. It wasn't 5 and 5. We don't know that it's necessarily cutting it in half, so we don't know it's 10 and 10. Just like this wasn't 5 and 5. Yes, dear?
You put another x, like...
Yeah, I'm going to put another x.
Yeah. So that'd be
But wait a
10.
sec. Okay, so let me get everyone else where we are, Dylan. So, if I said x was 3, what would you tell me that gray piece is?
17.
Okay, if I said x was 10, what would you tell me the gray piece is? If I said x was 15, what would you tell me the gray piece is?
5.
Okay, how are you figuring that out?
Because you're adding them together.
Oh, so you're taking the 20, and you're subtracting whatever number it is for x?
Oh.
So it's 20 minus x. Because you told me when this was 3, 20 minus 3 is 17. When this was 10, 20 minus 10 is 10. When this was 15, 20 minus 15 is 5. So you're actually doing that in your head already. We're just going to write it with math.
So it's 11 over 20 minus x.
It is going to be 11 over 20 minus x equals 14 over x. That is correct. Now, how will you know you've done stuff wrong? If suddenly when you start cross multiplying, you try to get an x squared. You've set up your proportion wrong for getting an x squared. This is not algebra 2 with trig. We are not that fancy. Okay, so you cross multiply, you get 11x equals, I don't know what 14 times 20 is.
280.
Can you explain one more time how you got 21 seconds?
Okay, so if I had known that this was 3, you would have said, well, that piece is 17. Because you knew the total was 20. You knew the whole thing was 20. So if that's 3, then this piece would be 17, because 17 plus 3 is 20. And if I said this piece was 10, you would have said the other piece is 10, because they got to add up to 20.
Yeah.
If I said this was 18, you told me it's 2. So what you're doing is 20 minus whatever this number is to figure out this number. Every single time. Now, would I have thought to write that like that if I wasn't a math teacher? No. But that's what it is. Okay, so it was 280, you said?
Yeah.
You added 14 to both sides. I'm running out of room. You had 25x equals 280. So x equals what?
11.2.
11.2.
How did you get 11.2?
Is it allowed 11.2?
How did you get that?
Did you add 14 to both sides and get 25x equals 280?
No, I got 280 minus 14x.
Okay, yes, we have the 11x equals 280 minus 14x. We have that. She's gone beyond that. She added 14 to both sides, got 25x equals 280. She divided both sides by 25, and she got 11.2.
Okay.
I didn't write all my intermediate steps because I'm at the bottom of my paper,
Okay.
so I can't.
Got it now.
Okay, I want you with your group to try number 4. When you have your answer, shout it out. I'll tell you if it's right or wrong. I'll show you how to do it in about 2 minutes, but my prayer is that you can get it right without me. Try number 4. What'd you get?
5.4.
If you got 5.4, then you know what you're doing. Flip over the paper, start on the worksheet. If you're still waiting, just wait and keep trying. You don't have to hurry. Yes, Natalie.
You put 6 over 14 and then X over 18.
You can. No, not over 18. Dude, you know how we did the 20 minus x because the whole thing was 20?
Oh, 2, 18 minus 8.
Yes.
Under what?
Okay, so
What y'all get?
I'll come over here and do it. You knew this was 18 minus x. So if you want to do what you want to, Natalie, you can do 6 over 14 equals x over 18 minus x. That's fine. I'm going to do it the way I've been doing it. I'm a creature of habit. I've been doing x over 6 equals, great, it's come to circle right, equals 18 minus x over 14. When you cross multiply, you got 14x equals, I don't know what 6 times 18 is. 108? Minus 6x. You add 6x to both sides, you had 20x equals 108. Then you can flip to the back and
Why
go,
would you?
did you add 6x to both sides? Because there was a minus 6x. Okay, and you got x equals 5.4. If you've got this, then flip it over and go on to the back. You can either be working on the 7.5 or you can be working on the 7.4. The 7.4 is going to get typed in later.
I got 5.4. Is that right?
Yeah,
See, what I did is I put positive 6 and I was
I know what you did. You did distribute. Maybe I did. I know what you did. Somehow you did, this times this is 108, and that times that is positive 6x. I know what you did.
Hey, help me on number 1.
Okay, if you've got your worksheet done like Dylan does and you want me to check your 7.4, bring it to me. Your 7.4, the one from yesterday, you weren't here. They worked on the worksheet that was we passed out the day before. That part he's already had done for you too. Okay. You need to be thinking.
You do the same for those.
I brought me the Dylan.
So for
I
number 2,
do that. You don't understand my way. 1, 2, 3. Those are the 3. Not you 3.
what I say? Oh.
What are you laughing at? So can you pass it? Yeah. That's right. Caleb. Yes.
With that one, would I
You can or do it the way you did the other. It doesn't matter. It doesn't matter if you do 14. It doesn't matter if you do 7 and 5.5. As long as you just it doesn't matter. You can do 7.5 and 5. It doesn't matter. As long as you 7.5. As long as you just it shouldn't matter. Yes. Yes. The whole thing's 16. Okay. I'm happy.
Okay, so for number 3, you put 22 over 20.
I don't like doing it.
Now let's do some special.
Yes, you can. I will text her telling you on the way. Hey, do me a favor and press. Oh, I forgot to call. Press off where Alex Ellis gets distracted. On the